Today's lesson will focus on completing the square from National 5. A quadratic expression involves an x squared term. When given a quadratic expression, we can complete the square. Doing this allows us to extract information about the quadratic, which we will learn in the future. Example 1. Write x squared, add 6x, subtract 1 in the form x add a all squared, add b.
In example 1, we're asked to complete the square of the expression which we've been given on the board here. When we're completing the square, we always check that the number in front of the squared term, which we will refer to as the coefficient, is positive 1. When this coefficient is positive 1, to complete the square, we will halve the number in front of the x when we write it in our bracket. So this will become x add 3 all squared. A half of positive 6 is positive 3. Whatever this number is squared, we will always subtract this. So we're going to subtract 3 squared, which is 9, and then carry down our negative 1. From there, we will tidy up. That leaves us x add 3 all squared, subtract 10. Therefore, if you were to break all of this back out, it would give you the exact same thing as you started with.
Example 2. Write x squared, subtract 4x, add 2, in the form x subtract a all squared, add b.
In example 2, we're asked to write an expression in the form of x subtract a all squared, add b. Same thing, we always check the coefficient of the squared term is positive 1. When that's the case, we are going to halve the coefficient of the x term. So that now becomes x subtract 2 all squared. Whatever this number squared is, we will subtract that. So 2 squared is 4, subtract the 4, and we carry down our positive 2. From there, tidy up. X subtract 2 all squared, subtract 2. So once again, we've taken this expression here and simply written it in a different format.
Example 3. Write x squared, subtract 7x add 3, in the form x subtract a all squared, add b, stating the values of a and b.
In our final example, we're asked to complete the square in addition to stating the values of a and b. To begin with, check that the squared term has a coefficient of positive 1. With this being the case, we then simply halve the coefficient of the x as with the previous two examples. Going into our brackets, we have x. A half of negative 7 is simply negative 7 halves, all squared. Halving something is always the same as dividing by 2, and in this instance, because it is a non-calculator question, we're easier to work with fractions. Continuing on our process, whatever this final number is squared, we will always subtract that. 7 halves squared is 7 halves multiplied by 7 halves. We will then multiply the numerators and we'll multiply the denominators to give me 49 over 4. Another way of thinking of that is simply square the top and square the bottom. From there, carry down your positive 3. We now need to look to simplify negative 49 quarters, add the number 3. Let's just write in the denominator of number 3. Any whole number has a denominator of 1. Carrying on, we now have x subtract 7 halves, all squared, subtract 49 quarters, and now we must change the number 3 into quarters. In one whole pizza, for example, there will be 4 quarters. In 2 pizzas, 8 quarters, which means in 3 pizzas, there will be 12 quarters. From there, we must then simplify down once again. We have x subtract 7 halves, all squared. Negative 49 quarters adding on 12 quarters gives me negative 37 quarters. We were asked to write it in the form of x subtract a, all squared, add b. Therefore, a will be 7 halves. Positive b is equal to negative 37 quarters.